All right, welcome to Chapter 2, Section 5, Solve Multi-Step Equations. And I forgot to erase my board here on the side from my last video. So we're going to go over this front screen just like we normally do. On your screen, you will see a due date. I just don't see it on my teacher preview, but you will on yours. After that, you'll see attempts. So I'm on attempt number 1 of unlimited attempts. This means I can submit this assignment as many times as I would like. I can just keep coming in and trying it over and over again. Number of questions, that just tells you how many are on this particular assignment. So there are 7. There's going to be anywhere from 1 to 10 questions, just depending on the section there. Grading policy, best score means that whichever attempt is the best one is the one you keep, and partial credit is enabled, so if you answer 1 of 7 questions, you do get credit for the 1 question. It has to be completely answered on that 1 question, though. It's not partial within the questions. This message on here, so please remember once you start the homework, you must finish it, so you can work on something else, anything else. So if I click start here, on your screen, down in the bottom right corner, you will see a Submit Assignment button. You always, always, always click the Submit Assignment button. Number 1, it puts it in the gradebook so we can see that you've been working on it and what the grade is. And number 2, it doesn't lock you out of all of your other assignments. If you just leave the screen without clicking the Submit Assignment button, Alex is going to assume that you want to continue working on that attempt. And it's going to lock everything else out and make you come back to this one. So it's just a very good habit. Always get in the habit of clicking that Submit Assignment button. And it saves your place. So if you're on number 5 here, you've gotten all the way there and you've gotten all of them correct, you still have them correct when you come back. So that's not going to change. We have the 3 tools on the side as always. Explanation will give you the solution to this question, not an example, this one exactly. So it's not going to give you the answer and then let you come type it in. So it's telling you you're going to lose your attempt on this question. Which is fine. Sometimes we like to see just the explanation on that question in particular. It was maybe we're tripped up a little bit, not necessarily on the problem type, but on that problem in particular. So you just have to come in on another attempt to try it. Example, this actually opens up another window here, which just shows us exactly what it's expecting us to do in this situation. And then once we're ready, we can just click close and we're good to go there. We can click example again for another example. Message Center literally opens up a message with this question attached so your teacher can see where to go help you. All right, let's go ahead and get started here. So we're going to solve for phi. So just like we did in the previous sections here, I'm going to write this out on top. We're going to use PEMDAS. PEMDAS never, never, never goes away. And this is for simplifying from left to right. We simplify. Simplify. Okay. And remember, you do multiplication, division from left to right. You do addition, subtraction from left to right. So those are together. So multiplication or division, addition or subtraction. And then with parentheses and exponents. Once we simplify, then we can go backwards. And we usually don't have to go past this point. We can use this to solve. So we look at what is being added or subtracted to my variable, and I do the opposite. What is being multiplied or divided by my variable, and I do the opposite. So we can kind of use it to do both. We just have to make sure we're paying attention how we're doing that. So let's go ahead and take a look at this first guy here. So we're going to solve for the variable. That means I want to get the variable all by itself. So here's my variable, and I want it all by itself. So I have to simplify this first because I have parentheses. So that's my very first step in simplifying. And I can do it one of 2 ways. I can distribute this 3 like this. Or, this is multiplication, or I could divide, since the entire piece is being multiplied here, I could actually divide both sides by 3 as well. Either way, we'll remove the parentheses. It just kind of depends on which way that you're used to seeing that. So I think in class we're more used to doing it this way, so I'm going to go ahead and stick with the distribution. So we have 3 times 2v is 6v. Plus 3 times 8 is 24, equals 60. So I'm completely simplified now. I don't have exponents. There's no multiplication or division that I can do on one side of the equal sign. And there's no addition or subtraction that I can do on one side of the equal sign. So I am at my solve stage here. So I'm going to say what's being added or subtracted on the same side as the variable. So 24 is being added. I'm going to do the opposite of that. Boom. So I have 6v equals 24 minus 24 cancels out. And then we have 60 minus 24. So we have to do a little bit of borrowing here if we're doing this in our heads, right? So we get 36. Now I can do multiplication division. So I'm multiplying by 6. I'm going to divide by 6 on both sides. 6 divided by 6 cancels out because it becomes 1. So this guy became 0. It was addition, subtraction. This became 1 because it's multiplication division. So this is going to equal 6. So I'm going to take a step back. Since I brought it up, I'm going to take a look really quick at how you do that with the division. So this is the OR. I could do it with distribution, or I could divide this 3 ways since the entire side is being multiplied by 3. So that's the other thing to be careful about. I don't want to divide if it's just one piece, but if the entire side is being divided or multiplied, either way, this one's being multiplied, or I can, if it's a fraction and it's all being divided, I can do the same thing. So 3 divided by 3 cancels, and I have 2v plus 8 equals 60 divided by 3 gives me 20. Now I still have to go through and solve. So I'd still have to subtract 8 from both sides. 2v, 8 minus 8 cancels. 20 minus 8 gives me 12. And I divide by 2, divide by 2. V equals 6. So it really didn't save me any steps there. I still had to go through and do the same number of steps, really. It just kind of depends on your preference and whether or not you notice that's an option. So I just wanted to bring it up since it's kind of the first one that came there. But either way, I get 6. All right, let's keep moving here. So we have negative 37 equals 5u plus 2 times 8 minus. So in this case, if I went and tried to do this idea where I divided by 2, the problem is I'd also have to divide 5u by 2. So that's the other thing to be careful about. The entire side isn't being multiplied by 2, only this piece. So this one only works well if it's the entire side. So just be very careful about that so that you're not forgetting to divide a piece here. All right, so I'm going to start off with parentheses here. Let's simplify this. 5u. 2 times u is 2u. 2 times negative 8 is negative 16. Well, now I have some like terms here. I have 5 of something and 2 of the same something. Right? That's a u is just something. That's what a variable is. It's something we don't know yet. So I'm going to combine these together and I get 7u. 5 plus 2 is 7. Minus 16. All right. So now, that was my addition subtraction, by the way. I went through parentheses. There were no exponents. There's no multiplication division we can deal with. Technically, that's what the 2 was multiplication division. But it was also dealing with the parentheses. So we were multiplying by 2 to simplify the parentheses, and we had to do that with multiplication. And then addition, subtraction, that was my like terms here. So I'm on my solving stage. So I want to get u by itself. So 16 is being subtracted. I'm going to add on both sides. And since they're opposites, I'm actually going to subtract, but 37 is definitely more. So it's going to be a negative number. But let me go through and subtract. So 7 minus 6, that's 1. 3 minus 1, that's 2. So I get negative 21 equals 7u. 16 minus 16, it doesn't matter if the negative's on top. I still have one negative, one positive. So I do the same thing I just did with 37 and 16. I'm subtracting. 6 minus 6 is 0. 1 minus 1 is 0. All right, now I can divide by 7 because I'm multiplying by 7. The opposite is division. Negative 21 divided by 7 is negative 3. 7 divided by 7 is 1. So u drops down by itself. So this guy would be negative 3. Check. What did I forget? Did I forget a negative sign? Negative 37. Oh, I forgot a negative sign. Ha ha ha. Way back at the beginning. This should be negative 5. So this would actually end up being negative 3 instead of 7. So let's go ahead and keep fixing this because this would change to 3 negative. And now I'm dividing by -3. So 2 negatives make a positive, and this wouldn't be 3, it would actually be 7. So I flip-flopped my dang numbers there. So forgetting that negative just on the very beginning, because I just didn't write it down. It happens sometimes, though we just have to go back and go, uh-oh, did I even write the problem down correctly? So always make sure that's the first step. If you get something wrong, go back and make sure that you wrote the problem down correctly, because it happens, obviously. That's a pretty easy thing to, oops, I forgot a negative sign in my problem. So just go back and check. If you did in fact write everything down correctly, then go back and start checking your steps and make sure everything turned out okay. All right. Do mistakes happen to everybody? Of course they do. We don't need to get upset about it. That's actually how we learn. So mistakes are something that we want to kind of happen there, because that's exactly what we need to happen so that we learn that process. Oops, I have to pay more attention when I'm writing my problem down. So -4 v minus 8. All right, I remembered my negative this time. All right, so same thing. Now this whole side is being multiplied by -4, but if I divide by -4, I have to remember it's both pieces divided by -4. So that one can be a little bit more difficult. So I'm going to go ahead and stick with the distribution here. We have 8v minus 28 equals -4 times v is -4v. -4 times -8 is positive 32. All right, so now I have no more simplification. The parentheses was really the only thing I had to simplify. So I'm going to go back through here, and I'm going to start combining my like terms. So I have 8v and -4v. I'm going to go ahead and add, I'm going to switch my colors here so that it's the solve stage, because we're moving things from one side of the equal sign to the other. So we're in the solve stage. So this is 12v minus 28 equals -4v plus 4v cancels out, and we have 32 drop down. All right, my variables are all on one side. Now I need to move this 28 to the other side. So 12v, -28 plus 28 cancels out. 32 plus 28, so we get 10 and 6. So now I can deal with this division, or this multiplication, by dividing. 12 divided by 12 is 1. V equals 60 divided by 12 is 5. All right, so we got 5 for V this time. Okay, let's keep moving along here. Ooh, now we have something a little different looking. Let's see, what are they asking us to do on this one? So for each equation, choose the statement that best describes its solution. So we have different types of solutions when we're looking at this. So far, we've had a variable equaling a number. And that's one solution that we know very clearly the variable equals this number. But we don't always end up with that situation. Sometimes we end up with a situation where we have a number equaling another number. Well, what we want to do, if we get down to the end and it's not a variable equaling a number, but it's a number equaling a number, we want to make sure it's true. So 6 equals 7. Well, that's not true. This is false, right? So this was just one I grabbed. I just wrote this down. It doesn't have anything to do with our problem yet. But this would be false. 6 does not equal 7. So what we do is we'd click no solution. Okay. But if we had something like 6 equals 6, okay, well, that is true. It's a little bit of a different solution, but it's true. So we go, okay, well, that's true. 6 does equal 6. So instead of one solution where a variable equals a certain number, we can say all real numbers are solutions. So we can pick any number we would like. And what it actually means is the line is on the x-axis if we were to graph this. It means that the line is actually right on top of this guy here. So any number will work. Because when we're looking for solutions, we're actually looking for where does it cross the x-axis. That's what we're asking you when we ask that question. Okay, so let's go ahead and take a look at these guys and see what we get. So I have blue here already selected. -3 minus 6u equals -2u plus 6. All right, we have two distributions to do here. So we're going to distribute on this side, and we're going to distribute on this side. So we have 4 times u and 4 times negative 3. So we have that, and then the negative 60 just comes down. That's not being multiplied by 4. That's not inside the parentheses. So again, be very careful about applying that correctly. Negative 2 times u is negative 2u. Negative 2 times 6 is negative 12. All right. So I want to keep moving here, and I want to combine some like terms. I have 4u and negative 6u. So 4 minus 6 is negative 2u. Minus 12 equals negative 2u minus 12. All right. Maybe we might already notice something about these two sides. So, in class, I know I was pushing on this one a little bit harder as far as, what do we notice here? Hopefully we notice something. Negative 2u, negative 2u. Negative 12, negative 12. What we hopefully should notice here is they are identical pieces. There's no difference at all between them. So if I start combining these pieces, say if I start trying to put the two u's together, because they're identical, I'm going to add. It doesn't actually matter which side, because I would add from either side. Well, negative 2u plus 2u, those are opposites. We subtract, and they go away. I'd have 12 equals negative 2u plus 12u, again cancels, and I'd have negative 12. So I end up with negative 12 equals negative 12. Well, that's true. Negative 12 does equal negative 12. It's just a little bit funny. The variables canceled. So as soon as I notice that they are identical on the sides, and they have to be identical, not even a little different. And I'm not talking about, like, I could have this. This still would work just fine, because all I did was switch the position. I still have negative 2u, and I still have negative 12. That's not what I mean by identical. I mean that the one can't be positive and one can't be negative on either side. Okay, so we have to have the same numbers with the same signs. Once I notice that, I can stop and say, ooh, this is all real solutions. But if I don't notice it, I can keep going until I end up with a number equaling a number. So it's perfectly fine if you don't necessarily notice that. All right, let's look at the second one here. We have negative 2y plus 2 plus 7 equals y plus 6. So we're going to distribute again on both sides here. So we have negative 2y. Negative 2 times 2 is negative 4 plus 7 equals negative 3 times y is 3y. 3 times 6 is 18. All right, and now we have some like terms on this side, so I can go negative 2y is, and it's negative 4 plus 7, so that would be positive 3. I subtract those, and the bigger number tells me that my sign. Okay, so now I can start solving, and I forgot to change my colors up here when I switched to solving, but that's all right. So let's go ahead and bring our variables together. So I'm going to add 2y to both sides, because again, I tend to like to have positives. Negative 2y plus 2y cancels out. 3 drops down. 3y plus 2y gives me 5y plus 18. And then I'm going to go minus 18, because now I'm just trying to get y by itself, right? So I'm going to do those same steps. So 3 minus 18 is negative 15 equals 5y. 18 minus 18 cancels. And I'm going to do my last step of dividing by 5. Oop, I'm getting to the bottom of my screen here. So I have negative 15 divided by 5 is negative 3. 5 divided by 5 is 1. So y. So in this case, I ended up with one solution. So I'd click on this one here. I'm going to type in, what did I get for y? It's negative 3. So again, when we're looking for no solution or all real solutions, we're going to end up with something weird that looks like this. A number equaling a number. If it's true, that's all real solutions. If it's not true, it's a number equaling a completely different number. That's not true. We click no solutions there. Oh, I don't know why that's zooming out. That's interesting. Don't really want it to zoom out. Okay. I think it zoomed out too far. There we go. I wanted to be able to see pen mouse. Okay, so let's go ahead and click check. And keep moving here. A couple more here. Oh, dang it. Silly thing, grabbing the whole screen. Moving it all around. Okay, so let's see. 6 friends went out to lunch. So we have 6 friends. And we can even picture this. right here. Ooh, that's a really funny looking friend. Her body's a little bit funny. 1, 2, 3, 4, 5. Here's 6. Da-da-da-da. 6 friends. So here's my 6 friends, and they went out to go get food. And I'm not good at drawing food, so I'm just going to go. They went to go get food. They each started with the same amount of money, and they each spent $8. They ended up with a combined total of $48. How much money did each of them start with? So they each started with the same amount. We don't know what it is, but it's the same amount. I'm just going to go like this, $sign. They ended up with the same amount of money here, right? Exactly the same amount. And I'm just using the $sign to be silly there, but it's whatever it is, the same. They each spent $8, right? So each of them spent $8. And they ended up with a combined total of $48. How much money did they have to start? So we first have to write an equation that could be used to answer the question above. We want to choose the appropriate form. So there's 2 forms. We're either going to choose addition or subtraction. Since they're spending money, I'm thinking it's going to be subtraction, right? And we're going to fill the blanks in with 6, 8, and 48. And let X represent the amount in dollars each person had to start. So instead of $sign, we're going to use X. So we're going to have X minus 8, what they started with minus what they spent. And then we're just going to look at how many friends do we have here. 1, 2, 3, 4, 5, 6. So they all did exactly the same thing. Maybe they all ordered the same food. We don't know necessarily why they all exactly spent the same, and they all started with the exact same amount. It's not a terribly probable question as far as, real world, but it's the idea of being able to apply this to a situation. So if we know that 6 friends had X amount of money and spent $8, and they totaled 48, that's how much they had left over. There's our equation. So we're going to go ahead and type it in down here. We have 6 and 8 and 48. So we've written our equation. Oh, why didn't 8 go in there? 8. All right, so there's our equation. Now solve the equation in part A to find the amount of money that each person had to start. So we're going to go through and we're going to start to simplify here. And I know I've got my colors mixed up, but that's all right. 6x minus 48 equals 48. Interesting. Okay, so it looks like, and I can kind of see they spent half of what they had left over. So that's interesting. Or half of what they started with. So we're going to go ahead and start solving. I'll flip it to blue. I know I had simplifying in blue and solving in red, but I forgot to change my colors when I started this problem. So minus 48, I'm going to add 48 to both sides. 6x equals negative 48 plus 48 cancels. So now I have 16, 8, 9. So I started with $96, or we, the whole group, started with $96. But remember, each friend had the same amount of money, so we need to divide that up between them and say, okay, well, how much did each of them have here? 6 divided by 6 is 1, so just x. Let's see, if we do this one, we have 9 divided by 6. That would go in 1 time with 3 left over, and then that would give me 36, so that would go in another 6 times. So that was a little bit of mental math. I just did this division kind of in my head. I could see that goes in once with 3 left over. 3 would drop down and give me 6, so this would go in 6 times. So it's just a little bit of doing some mental division there, thinking of it out loud. So they each started with $16, and they each spent half of their money, which is 8, right? So that's why we ended up with only 48 instead of 96. All right. Perfect. Let's keep moving here. Okay, so write 2 expressions for the perimeter of the figure. Note the figure is not drawn to scale, so they don't want us to do any kind of measuring. They don't want us to take out a ruler or anything like that. So if we're thinking of the perimeter of a figure, number one, we need to know that the perimeter means that we're going around the outside. So if this was like some kind of wonky shaped building, I want to know how far do I have to walk to go all the way around the building? Okay, that's what perimeter means. So really what we're just going to take is all these pieces and add them together. We don't necessarily know what X represents right now, but if we know what the perimeter equals later, we can figure this out. If we knew, you know, all the way around, we can figure out what the sides were. And it doesn't matter which one you start with. You can start with any number and just start working your way around. And it doesn't matter if you go clockwise or counterclockwise. Alex is not going to care which direction you type this in, or even if you type them in order. I can type them in out of order. It really doesn't matter as long as I have those 5 pieces being added together. Okay, so I started at 8 and went, you know, clockwise around here. I could have gone counterclockwise. I could have gone, you know, 7x plus 4x plus 8 plus 4 plus 2. Really doesn't matter what order I type them. That's part of the commutative property. I can move them around. It's not going to matter. Okay. So in this one, what it wants us to do is combine like terms. Simplify that expression. So the perimeter is going to equal, if I'm looking here, I have 8, 4, and 2. Those are my constants without any variables. So 8 plus 4 plus 2 is 12. And then I have 4x and 7x. So I want to add those guys together as well. So I'm going to have 11x. So it's just a matter of, you know, do I know what perimeter means? If I don't, definitely click on information here. I believe an example, and we can even click on it real quick. I believe it'll explain to you really quick what a perimeter is. So it's the sum of all of its lengths, and it shows you for this one, it's adding all the lengths together here. And then for simplifying, it's combining like terms, and they even color coded them for you, just like I like to do on the other screen there. So it's just that idea of combining like terms in another situation where we might have this expression. 11? Oh, that should be 14. Sorry about that. 14, not 12. 8 plus 4 plus 2 is 14. I don't know why I rounded that to, or put that to 12. Okay, so now we're going to look at the perimeter of the rectangle below. So we know the perimeter is 124 units. They're telling us that. The perimeter of the rectangle below is 124 units. And the word units just means they're not telling us it's feet squared or meter squared. It's just units, whatever it ends up being. Find the length of the side RS. So one thing we do need to think of on this one, and it says rectangle. So it looks like a square, but we're going to go with rectangle. We don't know that it's actually a square. So 4z plus 2, S, R, P, and Q. So we want to pay attention to the idea of a rectangle is that the opposite sides are congruent. That's what makes it a rectangle. So if the top is 5z minus 3, so is the bottom. If the left side is 4z plus 2, then so is the right side. So I have my pieces here. And if I want to know the perimeter, I just have to add all of those pieces together. And I can use multiplication here too. So instead of having to write, 4z plus 2 plus 4z plus 2, I can use multiplication to do this. I can say 4z plus 2 times 2, and I can do distribution. If I, instead of using this, if I just said 4z plus 2 plus 4z plus 2, that's also perfectly fine. That would work out just fine. So 5z minus 3 times 2. And we already know they told us that it's going to be 124. So we know together that's going to equal 124. So we're going to solve for z. That's not actually our answer. They want to know, what does this length actually equal, rs? But in order to know what that length is, I need to know what the variable z is. I have to know what it stands for. So I have to solve this really quick to know what this is. And we have two distribution problems here. So 2 times 4 is 8z. 2 times 2 is 4. And I cross my z's because apparently my z's and my 2's look very, very similar. So I do that on purpose so that you can tell it's a z, not a 2. 2 times 5z is 10z. 2 times negative 3 is negative 6. All right, let's combine our like terms because we have a couple of like terms here. So 8 plus 10 gives me 18z. 4 minus 6 gives me negative 2. All right, we have simplified all the way down as far as we can get. Now we are going to start solving. So 2 is being subtracted from the same side as the variable. I'm going to add it. 18z, 2 minus 2 cancels, and we end up with 126. And now I can deal with this multiplication here. I'm going to divide by 18 on both sides. 18 divided by 18 is 1, or just z. And in this case, we do have a calculator here, so if you don't know what 126 divided by 18 is, that's all right. We can use our calculator, and we get 7. So that one, I'll admit, I didn't know that one right off the top of my head. I would have to have thought about it for a minute before I jumped into knowing that one. But we can use our calculator. It was available to us on this one. So z equals 7. Again, that is not our answer. We do not want to type 7 in, because I want to go back up here and use this. I want to know what RS is, and I know RS equals 5z minus 3. So I'm going to plug this in so that I know what is the actual length of this side of the rectangle. So 3 times 5 is 35 minus 3, and that gives me 32. This is the answer I'm looking for. So this one required a little bit more. I need to know what perimeter is. I need to know what the qualities of a rectangle are in order to apply that correctly. We need to write in an equation relating the sides of the rectangle to the total perimeter, and then solve for the missing variable. Then we have to plug that variable back in to find the total length of a side, because it didn't ask us what the variable was. It asked us what the total side was. So just there's definitely a lot going on there. So that's a lot to think through as far as going through there. And a couple of those things, if we don't know what perimeter are and we don't know what the qualities of a rectangle are, that's going to kind of stop us in our tracks. But again, this example page does do a pretty good job of letting us think through it. So it says, in a rectangle, opposite sides have the same length, so we can think of the figure as follows. So they actually kind of show us a very similar one, actually, 5z plus 3 instead of 5z minus 3. But they show us the same idea, and they walk us through the same thing that I just walked you through. But if you don't know what these mean, you're going to have to take a step back and go, okay, well, how do I know what both sides of the rectangle are? They only gave me 2 sides. We know, hopefully, from elementary school that, the opposite sides of a rectangle have to be the same. That's what makes it a rectangle. We usually have 2 small sides and 2 long sides. But in this case, it looks very square-like, and I almost think if we work this side out that it would also be pretty much the same. Let's see. 4 times 7 would get us 28, plus 2 would give us 30. So it's a little smaller. So the left and the right side are just a little smaller than the top and the bottom in this case. Okay, so that was section 5. I will see you. Let's see, is there another section here? Scrolling down just to see. Couldn't remember if that was the end. So that is the end of section 3. Chapter 2. I will see you in chapter 3.